Hi, everybody. Can everyone hear me?
Yes,
Beautiful. And see me? Yes?
yes.
Everybody. Can everyone hear? Okay, very good. Yes, you do. Àtẹ́wọ́ ọpẹ́ sí Olúwa wa, tẹ́wọ́ gbọpẹ́ wa ò ọba iye. Okay. I thought I was actually muted for a moment. That's good. Can you all see my screen now? Are you all able to see my screen?
Yes.
Very good. As you said, we bring praises to God. Accept our praises. That was what I sang for a moment. So today, last class, we discussed wireless network attacks. We talked about the wireless security issues, the protocols. Today we will cover Module 11, Cloud and Virtualization Technology. What I want us to do really today is does any one of us have AWS account or Microsoft Azure account? I like AWS. Does anybody have, any one of us have AWS account? Yes or no? Use the chat. I need everybody to respond. Do you have AWS account? Do you have AWS account? I need everybody's response, please. Use your chat.
I used to have one. I'm not sure if it's still active.
Say that again.
I used to have one when I just started cybersecurity entry level. I'm not sure if I still have.
Okay. Okay, no problem. So today we are going to be looking at cloud and virtualization security. So, my first question to us is, have you ever used cloud before? Have you ever used the cloud before?
I did, but
Use the
I'm
chat, please.
it.
Philip, Philip, speak. You're saying something. I can't hear anybody.
Didn't hear a Professor.
I cannot hear any of you guys. This is my question. Have you ever used cloud before? Or have you ever used the cloud without realizing? Maybe you've even used it today without realizing. Yeah, Milton, which cloud did you use? Milton, which cloud did you use?
iCloud on Apple.
iCloud. Very good. iCloud on Apple. Anybody else? Philip said yes, a long time ago. Philip, do you have an iPhone? Philip, do you have an iPhone?
No, I don't. But I when I started the cybersecurity entry level, we we have to create our own cloud at the time.
Okay. Okay, you don't have an iPhone. Do you use a Android, right?
And for
What phone do you use?
I use a Nord 300 Android.
Android, very good. So, if you change your phone today, will you lose your data?
No,
Philip, if you change your phone today, will you lose your data?
no, I don't think so.
Why not?
Because everything is stored in a data form, data entry.
What data? What data form?
Um, I think it's the Microsoft. Well, it's gonna be in the cloud anyway.
Yeah, exactly. That's where I'm going with you. That's where I'm going with you. So you wouldn't lose your data because your data is stored. It's stored somewhere. So you've not used cloud a long time ago, Philip. You still use cloud today. Okay?
Yeah, I got you. You're good.
Yeah, so a lot of times we use cloud without even realizing that we are using the cloud environment. So yes, wanted to nudge you in that direction. Okay. But then with your data being somewhere, in the cloud, like you said, you will not lose your data. Um, is it safe? Or what are the pros and cons of putting your data in the cloud? What are the pros and the cons of having your data in the cloud? What are the pros and the cons of having your data in the cloud? Hmm? Sophia, do you wanna try? Sophia?
Sure.
Yeah, go ahead.
Um, the pros and cons of putting um your personal data in the cloud, it could be tampered with or it could be stolen. So you want to make sure that your credentials are secure. And your business data, you don't want anyone messing with your professional workspace.
Okay. Which part is the pro, which part is the con?
Oh, the pro, you're storing it in a place where it has backup.
Where it has backup. Okay, very good. Would you rather Would you rather then keep your data or secure your own data? Or should organizations secure their own data in their data center or trust the cloud? Should organizations trust the cloud service providers like AWS, Microsoft, IBM with their data, or should they just keep the data in-house in their data center? Hmm? Own data center, why, Sophia? Why? Philip, Milton, Devin, Kaelan, why? Should organization own their data center or should they put it in cloud? You guys are not responding.
Thinking.
Devin, you wanted to say something. Go ahead. Okay. If you have any question, please feel free to put your question in the chat. I will do my best to get to them and to answer them. Today we are covering cloud and virtualization security. So, as you would imagine, traditionally, if any organization needs to publish a service, an application, they will order hardware from the equipment manufacturer, like HP, IBM. They will order those hardware and they will actually plan properly so that when they are ordering those hardware, the hardware is able to cater for not only their present needs, but also their future needs. What do I mean by that? Say, for example, I want to start an online business. I know that the peak period for my e-commerce business or e-commerce site is Thanksgiving. Everybody knows, holiday period, Thanksgiving and Christmas, as well as Valentine's period, some from Mother's Day period. So it just makes the most sense for me to plan the resources for the peak period so that the hardware is able to cater for my customers during the peak period. Now, off-peak period means that the resources will be there, but they will not be fully utilized, or the return on that investment will not be optimized. And we'll also have situations where we had segmentation and we were making sure each server is rendering one service for security reasons. You want your database server different. You want your application server different. You want your web servers different. And so there's so much investment, capital expenditure that goes into procuring hardware. Then organizations started to think, why don't we maximize the use of these hardware? And say, for example, we have this server that has so much terabytes of hard drive as well as compute, the process, the RAM can do more. Why don't we use it for multiple applications? instead of having different server for different application. So first, there was need to maximize the hardware resources. Then came the virtualization software. So the virtualization software came as a way of using one hardware to create multiple servers. All right? That was where this whole cloud journey started. And so from using one server to one hardware to power multiple services, the big organizations, AWS, Amazon, was like, during Prime Day, we have so much orders. But when it's not Prime Day, we still have hardware. These hardware are already using virtualization software. So we still have hardware. Why don't we now start renting these hardware resources to other people, right? So it's like we are generating our own power with the solar panels that we have at our rooftop. And we are generating much more than we need. Why don't we sell some of these electricity back to the grid or to other people? And that's how the journey of cloud started. Amazon said we will start to share our hardware resources with other people. They just pay us for the utilization. If they use more, they pay more. They use less, they pay less. So that's how the story of virtualization and the cloud started, right? So by the end of this module, you will be able to list and describe the different types of cloud and their locations, their architecture, their model, and you'll be able to also describe cloud security issues and controls and explain virtualization. But one thing I would want to do is to actually start with virtualization, because virtualization came before the cloud, and because virtualization is the backbone upon which the cloud is running. So let's take it from virtualization, all right? So virtualization pretty much is the means of managing and presenting computer resources without regard to physical layout or physical location. What I already explained that. It is using the same hardware, like on my laptop, I have a virtualization software that helps me create virtual machines, right? So it's like you have this software that you can download and install on your own computer, and it's able to allow you to install other hosts or other virtual environments. For example, if you take a look at my virtualization software, this is VMware Workstation. There are two kinds. We'll go into that. On this, my same computer, this VMware Workstation allowed me to be able to run Metasploitable, which is an operating system that was curated for hacking purpose as a target. And Kali Linux, this is another operating system that was created as a penetration testing operating system. This is Windows 11. Everybody knows Windows is an operating system. I don't use Windows 11 on my own machine. My machine is running on Windows 12. Then there is a Ramba, which is a GRC application. It's running on Linux as well. So on top of this, my own computer, this is my computer. On top of my computer, I have 4, including my hosts, making 5. operating system, okay, that is running, okay? So that's what virtualization allows us to do. It allows us to be able to, let me show you. It allows me to be able to share the resources of my system. What are the resources on my system? My system, I believe, has these amount of resources: 400 and 500 gigs RAM, 500 gig storage rather, 16 gigs RAM, right? The processor is a Core i7. The CPU is at 1.9 gigahertz. You see the RAM, you see the storage. So it's allowing me to be able to, okay, I'm using Windows 11 actually too. So it's allowing me to be able to share these resources, these 16 gig RAMs, amongst other operating systems. So for example, my Metasploitable is using 8 gigs out of my almost 500 gigs hard drive. It's using 512 of the 16 gigabytes RAM. It's using, and then Windows. The Windows is using 8 gigs of the RAM, 125 gigs of the hard drive. Aramba is using what? And so you see the Aramba is also using 8 gig. Even though I have 16 gig, it means that I cannot start all of them at the same time because they are using much more than my hardware can give, right? Altogether, they require about 20 gigs RAM to run, which I do not have. This one is 2, this is 8, this is 8, that's 10, this is 512, that is 18, right? 16, 18.5, right? So, but what this virtualization software allows me to do is be able to do more with, that's what virtualization is. So what is installed is the virtual machines. These are virtual machines, okay? The host is the host operating system. The guest system is what is installed on the operating system, okay? So, and there are different types. Where is my mind tab? Yeah. So there are different kinds of, actually 2 types, type 1 and type 2, okay, of this virtualization software. And they are also called hypervisors. So the type 1 is a situation where is the software or is the type that runs directly on the hardware. You see, in my situation, there is a host operating system, which is a Windows 11 hosting everybody. But the type 1, there is no host operating system. It is by itself the host operating system. So it runs directly on the hardware. Example is VMware's EXSI and Microsoft's Hyper-V. Those are type 1 hypervisors, okay? Then from the type 2 runs on the host operating system like the one that I currently have. So type 1 is the hardware, the hypervisor itself, Hyper-V or VMware's EXSI. Those are 2 popular ones. Then guest operating system, and on top of the guest operating system, then you can host your applications. On the other hand, the type 2 is the one that I have. It's the consumer. Enterprises use type 1 for the most part. The type 2 is the one that I have, which is where we have host operating system, my Windows 11. the hypervisor, the VMware workstation. Microsoft's one is called VirtualBox or VBox. Then the guest operating system, and then the application. Okay, that's type 1 and type 2. All right. So then we moved again from virtualization, or we advanced the virtualization to say, okay, we're using. And these applications have different, they have to maintain their own libraries, separate libraries that these applications. So dependencies that the application needs to run. So they will have to each maintain their libraries. But what if we could get to a situation whereby the same application can share libraries? So that's where the containers came in. So we have a hardware, for example, you have Docker is an example of a container engine. They are also a kind of software. So we have the hardware, you have the host operating system, then you have the container engine. For example, Docker is an example. And so Docker can allow for multiple applications to share binaries and libraries. These libraries see them as, the recipes, the ingredients that these applications need to function, okay? So that's what a container application is. So it holds all the necessary operating system components that is needed for specific applications to run. That way, it reduces the necessary hard drive storage space and the RAM that is needed. It also allows for containers to move more quickly because the operating system does not have to be started. All right. Then a common application of virtualization that we also see is virtual desktop infrastructure. That is just a fancy name for virtual computer. So I have a virtual computer. So like I have a personal PC in the cloud. Okay. It is a process of running your user desktop in a virtual environment. So for example, some time ago, I wanted to hire someone from out of the country. And so they needed to be able to access resources that were here, not from outside of the country. And so the way to do that, because if they are trying to attempt to access it directly, they will be denied access. So the way I solved the problem was to give them a virtual desktop. Service providers provide this virtual desktop. For example, AWS provides what is called Workspace, Amazon Workspaces. Okay, that's their virtual computers. So what I created a virtual workspace for them in Amazon's East location, in their East data center here. And when I created that virtual desktop, I gave them access to it. So so I gave them access to it. All they needed to do is have this Amazon Workspace client on their computer. And once they click and log in, it will load their virtual computer. And they can, from that virtual computer, access all the resources that they needed to access here. I could have also solved the same problem with VPN, but what happens with VPN is that the IP addresses can continue to change. And so it can signal that, something is that it can trigger security alert. So I wanted them to have a consistent IP address logging in to that environment. Okay. So that's the use case for virtual desktop infrastructure. It is a fancy name for virtual computer, your computer being in the cloud. All right? What are the advantages of virtualization? As you would imagine, it reduces costs. It allows you to be able to move your workload. You just need to move that virtual instance. So the hosts become easy to move. Then you can actually start new virtual servers and, easily. Okay? You can start them as quickly as possible. Then it can also provide uninterrupted access to users, like the example that I gave. You can do it supports live migration. There's no need for downtime. You can move virtual machines from one physical computer to another without any impact. Okay? All right. So I wanted to cover that virtualization portion. We will come back to this portion of infrastructure as a code, which is where we will. Okay, maybe I should just talk about infrastructure as a code and then the risk here, and then go to the cloud. Okay. Before I continue, what are your questions? What are your questions? What are your questions? What are your questions? Okay. I don't see any questions. So let's talk about infrastructure as a code. What does this mean? Just the way virtualization has been introduced to the hardware compute environment. When I say compute, I mean RAM, storage, environment. It has also been introduced to networking or switches and our routers as well. So that's where the name software-defined network is coined out from. It virtualizes part of the physical network so that it can be more quickly and easily reconfigured. That is part of what made the zero trust architecture that we talked about when we were talking about infrastructure security possible. The ability to be able to separate the control plane from the data plane. So if traffic needs to flow through the network, it will receive permission from the software-defined network controller. If the software-defined network SDN controller verifies the communication is permitted by the network policy of the enterprise, and then once that is approved, the SDN controller computes a route for the flow to take and add an entry for that flow in each of the switches along the path. Okay, paving the way for that communication to occur. All right. So take, for example, it's like you have the data plane. The data plane is where you have the router that does this packet switching, other networking devices, your LAN switch. And then with the protocols used to communicate between the control plane. The control is like the traffic warden, okay? And then the APIs calling the different applications, the business applications and the SDN applications. Okay. So when software defined network expands to the wide area network, it is called SD-WAN. It's a virtualized service that connects and expands enterprise-wide area network over large geographical distance. Okay, so SD-WAN is designed, This designed to solve challenges associated with the wide area network, like integrating connectivity between service providers and the organization. So the SD-WAN allows organizations to be able to connect across wide geographical area network. Right? Right. Then you have SDV, okay? Software defined visibility. This is more so a framework that allows users to create programs in which critical security functions can be automated. Okay? So it allows network administrators to automate multiple functions in the network that responds to detecting its ability to signal to you monitoring, right? Adjusting traffic mode configuration for any inline security tool or additional IT operations management functions and capabilities. What are some of the security concerns with virtual? All right. As you would imagine, vulnerabilities, the host can be a single point of failure. All right. From an advantage point of view, though, let's pick the advantage point of view first of all. From an advantage point of view, virtual environments allows you to reduce capital expenditure. It allows you can, from a security perspective, it gives you an opportunity to test your patches by downloading them, to create a test environment before installing them on the production. All right, so you use virtual environments to test. You could use virtual environment for your penetration testing as your penetration testing environment instead of even allowing your pen testers to pen test your production. You create a pre-production environment like staging or test for all of security checks to be done. All right. A snapshot of a particular state of your virtual machine can also be saved for a later use. You can take a snapshot of the VM and use it at a later time or even restore from it. Okay. Then testing the existing security controls too. It gives you that sandbox kind of environment or security control test, like a secure environment, an isolated environment where you can conduct your testing. Virtual machines can also promote security segregations and isolation. All right, apart from being able to maximize or optimize resources. All right. Hi. Hey, James. What it also does is it also provides that isolation in form I mentioned earlier, sandboxing, where if a program or a file has malware with a virtualization environment created, you can, as a sandbox, you can allow that program to run in that environment for some time and see how it behaves to determine whether it is a malware, is a worm, whether it's a bot or a logic bomb. All right. So that's what those are the advantages. However, some of the security concerns is that Not all hypervisors have the necessary security controls to keep attacks. Security control, security tools to support physical servers. Not many of them are designed to support or to secure virtual environment. All right? VMs also must be protected from both outside network and from other VMs on the same physical device or the same physical computer. There is what is called VM escape. You know, when something escapes. A VM escape is when there's a breakout from a contained environment and it directly interacts with the host operating system. So something happens where the virtual machines, there's an escape of protection from the virtual machine to the underlying operating system. When that happens with the underlying operating system, everything running on that operating system, including all that virtual machines, are impacted. There is also what is called VM sprawl. VM sprawl is a situation where organizations create or engineers create VMs without proper oversight or management. And you know, they want to run this service, they start a virtual machine. They want to run this test, they start a virtual machine. Yeah, different. And it also happens to me, right? I think I still got a last bill from AWS of about maybe $30 or $28. And I'm not even using the workload right now. I know that there are services that are running that I should have either canceled or decommissioned or deleted. Because the reason I went in last month, I removed all the EC2 instances that I had, but I'm very sure that there is a service that is still on that they are billing me for. And I haven't gotten to it. So, but there are organizations too that run thousands of virtual machines, and engineers spin up their virtual machines like this. And so what happens when those virtual machines are not decommissioned, or where there is no proper management or oversight, or even the operating system of those virtual machines become obsolete, and they start to have a vulnerabilities, right? So you spin up a server, you don't bring it down, you don't update it, it's there, vulnerable, and it can affect all other servers in the virtual environment as well. Okay, so organizations use what is called within these Linux environments, they use security enhanced Linux. To the marketplace, the cloud marketplace, there are certain instances that have been optimized to a certain level, like hardened. Let me see if I could go into AWS. And I wanted to let you guys also know that AWS have free tier services. And so you might want to try their free tier services. They used to have it for 1 year. I think now they made it credit based. They give you certain credit that you can apply to enjoy the service for a period of time. Okay. So going to need my MFA. See. AWS. I have multiple AWS accounts, so let me see, make sure that I have the right one. I think it will be this one. 229560. Sign in. Not that one. Let's see which one it is. Try. Let's see, maybe it's this one. 849236. Still not. Let me try this one. 359. Fast first. And 35. Okay. No, 357922241. Sign in. Oh. Okay. Let me see, maybe it's this one. 811995. Uh-oh. Okay. I'm gonna try something else. I'll try another account and see. Let's take 5 minutes break. I'll figure this out and let's come back by 7. Let's take 10 minutes break, 7:05. Okay. Thank you all for your patience. Nature called and it took more than expected, longer than expected, I should say. So yes, I was able to finally log into my AWS account, the other account. And
Hey, Professor, does that cost money? The AWS account?
no, it's
Okay.
free
Oh,
to
sweet.
sign up. They will give you credits. Before now, they usually have 1 year free tier access, which means you have certain servers and systems that you could use for free for
Awesome.
1 year.
Okay, thank you.
Yeah. You would need a credit card though. However, the services are free. Some services, not all services. Some services are free for a period of time. So before now, it used to be 1 year. I believe now they now give credits. So people could, I don't know if people use up their credits before the 1 year ends, but yes. So take, for example, EC2 instances like the server or the computer, that's the virtual server. So easily you could just launch a server and get started like that. Until earlier I was talking about, let me see, instances. I'm sure I don't have any instances running. Yeah. I deleted, oh, okay, this is something I was using as my AI assistant on WhatsApp. So I hosted that here, but I didn't need it anymore. So, but here you will see all of the instances. Now imagine that organizations, enterprise organizations have thousands of this, and if there isn't proper management for those, you see, it's a problem. Then I believe I was talking about the marketplace. So if I go to instance, say for example, I want to launch an AWS instance, it will give me, it will give me, the most popular ones. But then I could browse for more in the AWS marketplace. There are more in the AWS marketplace. Take for example, these are all these are AMIs that are by AWS or available easily. These ones are AWS Marketplace AMI. So this marketplace is where even third parties sell their products. For example, Fortinet, if I said Fortinet is the next generation firewall. You see the VM, it can be deployed on AWS. So that's where you'll find some of the security enhanced. You can find security enhanced. For example, this is CIS hardened image of Windows Server 2019. This is CIS hardened image of Windows Server 2022. Remember when we talked about endpoint security and we talked about hardening your endpoints, closing unnecessary ports, and just in general, hardening the endpoints to ensure that it's secure. So instead of going through the route of manually hardening that endpoint yourself, you could legit just start using an image that is already hardened. So this is level 1 hardening. This one has level 1 hardening. You'll see others that have level 2, level 3. These are level 2 for Amazon Linux 2023. So you will see all of those. So take for example, I'm looking for security enhanced Linux service. There are several of them that this is a security has Linux, and it is PTG hardening, like this company is PTG, they hardened it and they are selling this Red Hat Linux 9. It's hardened at level 2. Okay, and the starting price is 10 cents per hour plus, and that's the cost of the software and the cost of AWS usage fee. Okay, so these were some best practices for admin is using hardened software already, virtual images already, and you can find those in the marketplace. Yeah. So let's answer this question. Then we could go talk about cloud. I'll conclude this conversation on virtualization, talk about cloud. So which type of hypervisor runs directly on the computer's hardware? Is it type 1, type 2, type 3, or type 4? Which type runs directly? There was no type 2, 3, there's no type 3, there's no type 4. Is it type 1 or type 2? Come on, guys, respond. Use your chat. So I mentioned earlier, yes, Philip, you're right, it's type 1. It's called the bare metal or type 1 hypervisor. I shared earlier, the one I have on my computer is type 2 because I have a host operating system, and then I have these different virtual machines running on VMware Workstation. So VMware Workstation is type 2, VMware ESXi is type 1. VirtualBox is type 2, Hyper-V from Microsoft is type 1. All right? Yeah. So, what did I do? Reopen, close tab. Now that we understand the backbone of the cloud environment, which is virtualization, now let's talk about the cloud itself, okay? Let's talk about the cloud itself. I shared with us how we got to the cloud, how we got from on-prem to the cloud, how the cloud came about. So the cloud is it's not the cloud in the sky, obviously. It's just somebody else's data center in a location that you don't know, all right? The organizations may know, but it's not available. It's not information that's available to everyone. And, until I joined AWS as someone who works in security assurance there, that I knew that a location that I've been passing by, from time to time is actually an AWS data center. Because now, this time, I had to go in to the data center to get some work done, all right? So you may be passing by a cloud or data center and you wouldn't know. You will see their warehouses, those are marked, the offices are marked, but the data centers, you can never see a sign indicating that this is an AWS premise. Okay? So cloud computing in general is just somebody's data center sharing their resources, their compute resources with other people, with other organizations. Those that offer these cloud services are called cloud service providers. The consumers are called cloud service customers, CSPs, CSCs, okay? So the cloud computing, like we already established, has elasticity. What does that mean? And scalability, what does that mean? I could spin up a server right now. I didn't have to go to HP to order hardware or to IBM to order hardware. I could just come here, start an instance right now. But I'm not. Launch my application right now. Okay? And they have different services. If you look here, you'll see the difference there. Oh, wait. What's going on? Okay. You see all the different classes of services that they offer. Analytics service, application integration service, blockchain services, business application. I can consume these services right here, right now. That is elasticity. And that's on demand. Elasticity is when, and scalability is when utilization increase and there's automatic spin up of new servers, new instances. Okay, this is peak period. We need more resources. You're able, more resources spinned up automatically, right? Then pay per use, you pay for what you use. You use more during the peak period, you pay more. You use less, you pay less. Like if your HVAC heater at home is gas, you know that winter period, you pay more. Summer period, you pay less, right? Then it's on demand, like I said, I could just start a service now. And then it's resilience, means that, you know, you could, because it's elastic, it is on demand, it also offers high level of availability. So take, for example, if you look at AWS, they have different data centers and they have different regions. Where they say, for example, this is North Virginia. This is US East 1 data center. They have US East 2 data center. US East 1 is a region. Within this region, what makes this US East 1 is not one data center. It's multiple data centers. And your data is replicated across those data centers to offer resilience. Just in case one data center goes down, you will not lose service. Okay? All right. So I already went through this process of where we used to have our on-prem, but now there is cloud. All right, you don't need to start you don't need a major capital expenditure to get started. Okay, again, on-demand self-services, the universal client support, which means that you can have desktops access. You can access it from your desktop, from your laptop, from your tablet. Then there is resource pool. You have a lot of resource pool. What do you think is happening behind the scene when you're spinning up more servers, right? It's the virtualization software allowing multiple tenants to be on the same server, to be able to consume the same pool of resources. So the physical and virtual computing resources are pulled together to serve multiple simultaneous customers that are dynamically assigned and reassigned based on the customer's need. So the customer has little or no control of what is going on the physical server. It's none of their business. Then you have that immediate elasticity. Resources can increase, it can reduce. Again, it's metered service. There are different types of cloud. And when you say types of cloud, we were talking about deployment model, okay? So you have the public cloud. The public cloud is the one that everybody, where the services and the infrastructure is offered to all users. For example, these AWS one, IBM Cloud, Microsoft Cloud, Oracle Cloud, all of them. You could, I think some of the newer ones, I think it's DigitalOcean. Yeah, you have DigitalOcean and some others. So these are public cloud. All users have access to them through the internet. Then you have private cloud. Private cloud is not different from you having your on-premise data center. So private cloud is just your on-premise. You create and maintain your home private network. Then you have community cloud. Community cloud is used when is set up specifically for organizations that have common concern, common need, common goal. For example, AWS has a separate environment that they call Gov Cloud. Gov Cloud. That Gov Cloud is for government entities. So you see those Gov Cloud, you can't see Gov Cloud, these are public. These data centers are public data centers. But if I go here, it says there are 17 regions that are not enabled for this account, that's fine. If I go here and say manage regions, you see that the AWS Gov Cloud. So take, for example, Gov Cloud should be somewhere, AWS Gov Cloud. It says to sign up for AWS Gov Cloud. It's US for US government agencies and entities only. Okay, because they have common goal. For example, they all have to meet FedRAMP requirements. If I attempt to say, I want to launch, no way, access to AWS Gulf Cloud region has been denied because you did not meet one or more of the prerequisites. Please contact AWS customer support if you believe you received this message in here. I didn't receive it in here. Okay. All right, so that Gulf community cloud, same level of requirements. Okay. Do we get it? And then hybrid is where you have a combination of public and private. Take, for example, we have our primary data center, but we use cloud for backup. Okay. Or take, for example, we have primary data center in the US, but in Canada, due to certain requirements, we are exposed, we can only launch, for example, data sovereignty. We can only serve Canadian citizens from Canada. So we have to set up another environment in that's hybrid. Okay. All right. So cloud location, instead of the centralized model, cloud computing provide decentralized model. So when they say US East 1, before AWS, look at the regions and the locations. I mean, during my time at AWS, I helped onboard several of their regions and locations into the compliance programs. And before they could, when they start a region is not a data center. It's not one data center. It's not one location. 3 data centers make up a region, or what they call availability zone. And so all those availability zone combined makes up one data center to give that resiliency that we talked about. Right. So even though it is looks centralized, it is decentralized. Okay. Then we have on-premise resources like our local area network data centers and desktop. Off-prem, of course, remote facilities, your cloud services. Then we have fog. You know the way fog is. It's a decentralized computing infrastructure where data, compute capabilities, storage, and application are located between the data sources and the cloud. For example, there are some automated guided vehicle that can be on a shop or on a floor that it is remotely controlled. So that's an example of fog. We also have edge computing. Edge computing happens where data is made available at the nearest location to the consumer. Okay? It's performed near. For example, you know the way you will have those top 10 movies on Netflix? Yes. Instead of when Netflix sees that, when AWS or Netflix, I should say, sees that there are so many people in this area that want this service or that are watching this movie, instead of this movie loading directly from its original source, they can put it on some edge computers or edge content delivery servers. And those content delivery servers are close to you. You wouldn't know, but a lot of times these cloud service providers, they partner with your telecommunication companies because they know that your telecommunication companies have data centers and base stations close to your homes. So they partner to locate some of their services, especially in areas where the population is dense, right? They partner with the data centers, with the telecommunications side. So Verizon, you see a data in Verizon location, you see AWS there, or they do that. And so that is to provide these edge computing services. Then we have the cloud computing services themselves. These are often located in the data center and the main computing facilities. Okay. When it comes to the cloud architecture, though, there is a thin client. For example, I showed us earlier about the virtual desktop. I explained the virtual desktop computer, right? Where it's just a computer that is in the cloud that I made available to someone who had worked for me before. How do they access that desktop? That desktop is in Virginia, in AWS data center, but they are somewhere and they are able to use that computer. How? They connect through thin client. So the thin client, and I showed us that thin client, which is that Amazon Workspaces application that I opened up earlier. It's just an application like a client that was running on my computer or could run on their computer. And from that thin client, and you could also access it from the phone too. It's available on the phone. So this is it. As this client, I already deleted this. I could just register and log in, but this registration is incorrect. If I could start up a workspace services now, Amazon Workspaces, if I go here, I search for workspaces, it should, no, workspaces. So this is workspaces. It says this is desktops in the cloud. All right. And this is a thin client too, affordable, easy to manage thin client for secure access to virtual desktops. So the thin client is what is used to log into the excuse me, Ooh, desktops, right? Okay. Then we have transit gateways. In the cloud, your data center in the cloud is called the VPC, the Virtual Private Cloud. The Virtual Private Cloud. So in my, excuse me, oh, in my own case, my own case, hold on 1 second. What am I doing? Hold on. I'll go home. Ooh. So you see, these are all the services, right? These are all the services. Now, my whole network, one moment. Okay. So you will have under the networking and the content delivery, you see the VPC. The VPC is your virtual private cloud. That is your data center. So your VPC, so my VPC is in the Northern Virginia region. You see all the endpoint services, the NAT gateway, you see everything that is network related under the VPC. Okay. So in between the VPC and say, for example, an on-prem service. So take, for example, I have a service that is on-prem and I want my cloud service to also consume that, or I want my on-prem server to consume service that I have in the cloud. Have some transit direct connect is a gateway. This API gateway is another gateway. If you look at direct connect, this is a service that allows your I'm currently on a free plan. Oh, okay. But also I'm currently on a free plan. No, I'm not planning to upgrade. All right, so that is one that allows you to expose certain services. The transit gateway allows you to expose certain on-prem service to your cloud or your cloud service on-prem. Okay. Then we also have what is called serverless infrastructure. Is one in which the capacity planning, the installation, the management are invisible to the user because they are handled by the cloud provider. There are some serverless, for example, you have a service called AWS Lambda, okay? So while this EC2, yeah, I believe AWS Lambda is Lambda serverless. I believe it is serverless. Hold on. Is AWS Lambda serverless? Yes, yeah, okay. Yes, it is serverless. What does it mean? It means that it is not like there is no server, but it's just that the server is not your business as a cloud service consumer. It is a platform that you come to run your code. You don't need to manage servers. See, AWS Lambda run your code without managing services. Focus on your application, not your infrastructure. Lambda automatically provisions, scales, and monitor while you build. So you don't need to, it's unlike the EC2 instance where you select the operating system. No. With serverless infrastructure, that is handled by the cloud service provider. And that brings me to the cloud model. So there's a cloud model that is called software as a service, another platform as a service, infrastructure as a service, and there's a concept of anything as a service. We'll come to that. Now, take it from service. Infrastructure as a service is an example of infrastructure as a service is what I showed you with the EC2 instance, where the cloud service provider allows customer to deploy and run their own software, including operating system and application. So the infrastructure as a service is like renting an apartment. Who is it for you? You, right? Who buys your dishes? You. Who buy your dish? Who buys your, you furnish and do everything yourself when you rent an apartment. Okay, so that's infrastructure as a service. It starts from you selecting the EC2 instance, which is your server. You manage your own operating system. You're in charge of patching your operating system. You're in charge of your access control. You're in charge of all the applications that you install on that server. Then we have platform as a service. For example, that Lambda is a platform as a service service. So it allows consumers to install and run their own specialized application on the cloud computing. Think about this as Airbnb. And you go to Airbnb, it's already furnished, right? It's already furnished. All you need to do is come there, sleep, wake up, make your food, you already have that platform. Okay? Infrastructure is when you have to furnish your apartment or when you have an apartment or rent an apartment. Platform is when it is fully furnished, like your Airbnbs. You just bring your code. So example of infrastructure is the EC sense. Google Compute. We have the platform. Example of the platform is the Lambda that they just said, just come and run your code. We'll manage every other thing. I think they also have apart from that, part of their database service that is platform is Elastic Beanstalk, I think, who fully managed MongoDB, Amazon Document DB. I think is this the see. Hold on, let me see. Beanstalk. If they haven't, yeah. Okay, so for example, this is another example of platform, Elastic Beanstalk. And what does this do? It helps run your web service. Just come and run your web services, right? It says end-to-end web application management is easy to use service for deploying and scaling web application and services deployed with Java, this, that. Okay. Then you also have the software as a service. Think about software as a service as if you getting dark in the All right. So, software as a service is a situation where the vendor you just have access to the application or to the service or to the software, I should say. So think about this as going to a resort. Maybe everything is paid kind of resort. All you can eat. Everything is taken care of. So, in Airbnb, you have to still cook your own food and when you mess the bed up, you make the bed. But when you go to all paid resort, they lay your bed every day, you get your food, that's how you should see software as a service. An example is your Instagram. Do you know what operating system Instagram is running on? No. How often they update the services? No. How often they patch the services? No. What server architecture it is? No. But guess what? You use the application. All you need is your username and password, right? Your social media, those are software as a service. ERM solutions, Salesforce, those are software as a the device that behind or what infrastructure is powering Canvas. But we do have our username and password to log into Canvas. Okay. So, typical of every application architecture, you will have your database, internal, your application servers, and then your web services as the web services that the users will interface with, right? And so the cloud makes it also possible where you have your web services, there's a security group in between right here that is used to inside, in and out. That is also used to launch new web services if needed at the peak, when there is a peak period. And so all the good stuff is happening here. There's load balancer, there is access control, there is load balancing, and all of that happening. Okay. Questions before I continue. Questions. What are your questions? What are your questions? What are your questions? What are your questions?
No questions for me, Professor. I'm good.
Okay, very good. All right, so then we have how do we then there is need to properly manage the cloud services. But before I remember that I didn't talk about anything as a service. When I talk about anything as a service, is a broad category of subscription services. For example, security as a service, access as a service, managed services, anything as a service. There are services as a service, right? So anything as a service is a broad concept of subscription to services that are relating to cloud computing. Okay. And sometimes it's even used broader than that. Then we have cloud management. Cloud management, how do we manage these environments? Okay. It can be conducted by an organization's team or by a third-party management providers. And so on a continuous basis, as organization launch new features and launch new services, There is need for continuous development and continuous integration. So, and the integration services is, or what is called service integration, is attempt to achieve a boundaryless approach. What does that mean? Integrating users across enterprise who are using the cloud computing, or integrating services as well. You have your application service. Application service needs to talk to the SMS service so that SMS can be sent to users when they want to authenticate. You know, all those services need to be integrated one way or another. It could be through API calls or anything like that. Okay. When organizations don't manage their service locally, then they have what is called, they outsource the managed service provider. These are service providers that manage the organization's cloud infrastructure for them. They support, they administer the organization's resources. We'll also have MSSPs, Managed Security Service Provider, which is a full suite of security service being provided by third parties, just like outsourcing your security team to a managed service provider. Okay. Right. What are your questions? So earlier I talked about containers. Traditionally, applications are designed to be monolithic. What does that mean? The entire program is developed as a single entity. Like, so this is a whole program. That program will have its own application, will have its own dependencies, will have all the services that it needs. It will have its own. Then there was now need to, with that approach, with the monolithic approach, if one thing fails, troubleshooting becomes really difficult. It becomes a daunting task. But it's different from when you now break the different services down and convert them to small microservices, so that if something fails, you know the exact service that failed. Is it the database service that is failing? Is it you will know which services fail. That makes a lot more the architecture and troubleshooting to be better managed. So we used to have this monolithic architecture where you have data access, the logic of the business, the UI, everything working together. But with microservices, like you have all of these different microservices separated. Okay. Quick knowledge check now. Our CN has been given a project to manage the development of a new company application. It wants to use a cloud model to facilitate deployment and development. It wants to facilitate development and deployment. Which cloud model should he likely use? Software as a service, X as a service, IaaS, or PaaS? Which one? If you say platform as a service, you will be correct, because it wants to fast track development and deployment, and you just need to get started and going. Okay. For cloud-based security, because virtualization is the backbone of cloud-based security, every security control for virtualized environment also applies to cloud computing as well. Okay. And when it comes to cloud-based security too, the responsibility there are two, depending on the kind of services that you're consuming, the responsibility can be shared between the cloud service customer and the cloud service provider. So if you are using infrastructure as a service, for example, you will not expect the cloud service provider to patch your operating system. Okay? If you are using software as a service, the service provider will not expect you to patch their operating system. All right? So that's where what we called the cloud responsibility matrix comes in. I think the cloud responsibility matrix should actually be a picture of it here as well. Yeah. So that's where this cloud responsibility matrix comes in, right? For on-prem, the organization is responsible for everything. For infrastructure as a service, the cloud service provider is responsible for the physical location, the physical network, and the physical host. But from your operating system level up, the organization, you are responsible. When it comes to platform as a service, there is shared responsibility between identity and directory infrastructure, applications, and network controls. From operating system down, that is the cloud service responsibility. For SaaS, everything from applications down, this cloud service provider is responsible for. But when it comes to the information you share, data you share, there, it's your responsibility. The devices that you are accessing through is your responsibility. Your accounts, keeping your password secure is your responsibility. All right? Then when it comes to identity and directory infrastructure, it's shared responsibility because, for example, they make the two-factor authentication feature available to you, but then you have the responsibility to use it and keep your tokens secure. Okay? So it's shared responsibility there. Okay? All right. Let me take a pause. What question do you have before I go back here? So when it comes to securing the cloud, yes, there are so many security solutions that is available as services. So if you go here and I go under security, identity, and let me see all services. It will show the categories. So I go all services. Come on, come on, come on. Okay. It was showing me everything earlier. I don't know why it's not showing me everything. It's showing me. So let's look at security. All right. So we have AWS Artifacts. This is where they put all their compliance reports. This is Audit Manager. They use it for access control for GRC, for managing audits. It is a service that they provide to organizations to manage audits. If you want to manage your own SSL certificate, if you want to manage your HSM, remember when we talked about identity and access management? You want to manage your HSM, they have service for it. You want to manage your federated identity. Say you want people to log into your application using their Google account. Identity federation. Remember when we talked about IES, detective service to look to find potential security risks. Directory services, that's your Active Directory for managing access. They have a firewall manager as well that is a central management for their firewall rules. They have guard duty. Guard duty is for threat detection. Identity and access management for just what it is. The same thing with identity center, right? Then they have inspector, that's their vulnerability management. Then key management solution. This is a machine learning. Amazon Base is a machine learning service that is used for data classification. Yeah. So yeah, you see the different security, they have WAF, different security services that they provide. So when it comes to cloud-based security, you have the option of, like they have CloudWatch. They have audit trail or something. Yeah, I think they have audit trail. Managing what you call the whole happens. Maybe they discontinued it, but yeah, different security services and organizations can make the most of those security services. The ones that the cloud service providers don't natively have, you can get them on the marketplace, like those Fortinets. Those are security appliances as well. Then we also have the concept of cloud access brokers. These are a set of software that resides between your on-prem infrastructure and the cloud provider's infrastructure to brokerage access between. They are like the gatekeeper between your on-prem service and the cloud infrastructure. We also have what is called SASE. This SASE is a convergence of so many security services together. There was this company that I met in one of the conferences. They are called, I think they are called this name. All right. There are different companies that provide SASE. If you look for Gartner SASE, you should be able to see the different companies. So let's see their solutions. Let me see. AIC guard. Okay, these are later. These guys provide, oh God, man. They provide SASE services, which is a combination of multiple security services. So they could combine these security services together to make for a SASE environment, and it is of the SASE service. So it's this convergence of cloud services that is delivered as one. So like the secure gateway, cloud access brokers, ZTAs, WAN technologies, that is like more, it's like the UTM. Remember when we talked about unified threat modeling solution? No, unified threat management solution that does anti-malware, that does URL filtering, and all of those good stuff. Yeah, this is like the UTM of the cloud. Okay, right. When it comes to vulnerabilities, unauthorized access. The last class, we looked at how Shodan can be used to identify S3 buckets. Remember, S3 bucket is the storage for cloud services. So that means that if the storage, if that S3 bucket is not properly configured, it could be exposed to the internet, and that's organizations' data in the wild. Then lack of visibility too. Sometimes organizations have limited or no visibility into the security mechanisms on the cloud service provider, and thus it cannot verify the effectiveness of security controls. So because you don't have physical access, you don't have network access. In fact, unless you are a tier, so even as an Amazon employee back in the days, as an AWS employee back in the day, my regular badge is different from my data center badge. There's a different name, but it's different. The stripe, the look, the feel is different, right? So, many organizations don't have physical access to this data set. Even organizations that have audit rights, they are often not allowed to go to these data centers at all. The most they could do is to come to the offices and sit down and ask questions and respond to their questions. Then there could be insecure APIs because the means of exchanging information between different services is APIs. The API is like the way one of my students puts it. He says it's like the restaurant server or the attendant in the restaurant. It takes your order, it goes to the kitchen, they make the order, gets the order, brings it back to you. That's how APIs work. You make an API call, request for a service, the API gets that service, delivers it to you. So this API helps cloud service customer customize their services. It could also be vulnerable. So it's also important to actually secure these APIs. Okay. Compliance regulation too. Organizations that requires regulation, it could also be an issue. But then they have all these rights. If they are big enough, they are big enough and push hard enough, they will be allowed to audit these cloud service providers. Then we also have vulnerabilities on the network. There could be misconfiguration. For example, in November last year, I believe the entire US system was down because of some DNS Route 53 configuration, right? So it could also be situations where it's not within your control. Entire canvas, so Netflix was down. So many services were down as a result of that. So those are some of the challenges that can happen with the cloud environment. In fact, when I was working during my time at one of those SaaS companies that I worked for, one of the questions that we see in compliance program is requirement asking us to provide our backup plan just in case the cloud service provider site is down. And sometimes I think about it, these guys know what they are doing. They are always available. They provide us 99.9999 availability. So what are we talking about? But as I started to see some of the major failures and service issues with this cloud service provider, I'm like, this compliance standards know what they are looking for. All right. So while the physical network use the OSI model, the cloud computing does not use OSI model. So troubleshooting, you have to be very strategic when troubleshooting because there is no single concept to be able to, a single model that is widely accepted to be able to troubleshoot where your problems or service failures might be coming from. Okay. How do we then secure the cloud? Conducting audits. A lot of organizations have audit rights. They don't utilize them, but yeah, conducting audits using different regions and different zones. So if you have your main site in US East 1, you might want to go to US West to use as your backup, just in case something happens. So leveraging that, duplicating your services across different regions is very helpful. Using strong authentication mechanisms and managing the secrets properly is also a way to secure the cloud environment. Then, securing cloud can also involve controls such as enforcing functional area mitigation. When it comes to hybrid cloud, this comes with special challenges because it's a mix of the two. So your gateways, securing your gateways, securing the edge computers is very, very important. Right? Best practices for hybrid cloud is encrypting sensitive data as they are traversing the network, monitoring and audit configuration, and use of automation rather than manually managing things, regularly scanning for vulnerabilities, securing all endpoints, and of course, zero trust architecture. Okay, so based on the common responsibility matrix, which of the following is a cloud service provider not responsible for? Not responsible for. Which one is a cloud service provider not responsible for? Devices, physical host, physical data center, physical network. If it says devices, then you will be correct because everything that has to do with physical, the cloud service provider is responsible. Everything physical. The device you're connecting with, they don't have control over. So everything physical, they will be connected to. So we've covered everything that has to do with virtualization, and I know it's a lot of information to digest. It's a lot of information to what's the word now? It's like drinking from a fire hose, So this is unlike our regular term where we have 8 weeks or 12 weeks to cover this and 3 hours per class, where we do a lot of labs as much as show and tell as we are able to. But I will encourage you to take time to research more of this concept on your own as well. And if you do have questions, I'll be more than happy to help answer those questions. What are your questions? Okay. In the absence of any questions, we are wrapping things up. Today is Wednesday. I'll see you guys back here tomorrow. Tomorrow, I believe we are covering, what are we covering tomorrow? We are covering bond management. We're covering vulnerability management tomorrow. So I'll see everybody here tomorrow. And have a good rest of your evening. If you have questions, let me know. James, you
Okay.
have questions?
No, ma'am. Nope, I'm good.
Okay, all right.
It's so much. It's so much.
I know. All right, everybody. Have a good rest of your evening.